Going to be looking at in 2.2 is linear functions. A lot of this you probably have in your background. It may be a review for a lot of you. Some of it may be new, but we're going to just do a quick overview of linear functions. Okay, so first thing we're going to talk about is the idea of what a slope is. And if you're going to go on like and take calculus and stuff, the slope is a really big deal. It's really central to that class. So when you're doing a slope, that's telling you basically how steep a line is. Like you can have a line that's very, very steep, and that would have a positive slope, or you could have a line that has a very small slope to it like that. I always think when I'm teaching this, I think about, if you're coming back from the mountains to Denver, you're going way downhill and it's pretty steep. So they always have this sign that says, warning, 7% grade. So they're really measuring the slope, because if the slope gets too steep, they want to warn truckers to get down in low gear so they don't burn out their brakes and everything. So we kind of use that for different things. So basically, these are the general formulas that we're going to be talking about. Just think of the slope as a ratio of the rise and run. This is just saying change in y and change of x. We're going to talk about what that is in a minute. And then that's the general slope formula like that. Probably did some of that in high school or whenever. That's a common thing that you're going to talk about in an algebra class. So it turns out there's 4 possibilities, and if your line is going up, that would be a positive slope. You can write a note down that if you want to. If your line is going downhill, we would say that's a negative slope. It has a negative value. If it's going straight up and down, like this one, that's an undefined slope like that. And then if it's this way, if it's perfectly level, that doesn't have any steepness, so that slope would be 0, like that. This diagram, I just kind of saw this on the internet. Now what it was showing is all of these slopes here, this one, 1, 2, 3, 4, 5, all those lines there are positive, and they're getting bigger. So that slope 0, a third, a half, 1, and 2. So the idea is the steeper it gets, the bigger the slope gets, if you're talking about positive slopes like that. Okay, that stupid thing I found on the internet. Sometimes I'll Google stuff and I'll find stuff that teachers have come up with. So somebody came up with this silly diagram and said, okay, that's positive slope, negative slope, undefined slope, your nose, and then the mouth is 0. Whatever helps, okay? All right, I just saw that and came across that the other day and thought that was funny. All right, so what we're going to do is we're going to work out crunching out slopes, okay? All right, so what we want to do on this problem right here is let's just find 2 good points. It doesn't matter where you are. I'm going to just have you put like a dot. Let's put a dot right there, okay? That's a nice good point. That's the point that looks like -4, -4. Okay, I'm going to find another good point, okay? And I'm going to go here. I mean, it doesn't matter. As long as you find a nice, simple point that doesn't have any fraction values, that's the point 0, 4 like that. So what we're going to do to start with is just count this up like this. So the rise, all the rise means is what's the distance this way? So you could count and just go 1, 2, 4, 6, 8. Or it's how far apart are the y values. 4 and -4 are 8 apart, right? So what you would have is you could say the rise on that is you're just going like up 8, and then the run is going this way. And then the run is just saying, what's the distance between those x values? So how far apart is -4 and 0? What's 4? So what you would be doing is that run on that, you would be going to the right 4. So the slope's the rise over run. So you just say 8 over 4. So you get a slope of 2. Okay, that's what that is. That's a positive slope like we talked about. So it goes like that. Okay, is everybody with me there? Okay. Now, you can do this the other way. I'm not going to do this on every problem, but it doesn't matter where you start. If you started at this point and went down, then that would be a rise. Anytime you go down, you use a negative number. So that would be down 8. And if you did your run, since you're going to the left, that would be -4. Okay, so you get the same answer. You would say rise is -8, run is -4. Notice that you would get exactly the same answer. So it doesn't matter which way you count it. Okay, and it's real logical. Up is positive, down's negative, right's positive, left's negative. Okay, everybody with me there? Okay, just want to be consistent and you can count that back both ways like that. Okay, I'll let you guys go ahead and crunch that one out. And you can do it both ways, or you can just do it one way. I think number 2, I've got that graph on there like that, and just figure that out. You can use the 2 points that I have on here because they're both kind of got whole numbers in it. Well, let's make sure we can get all that taken care of then. I'd probably on this one, I'd just go down and right is what I do, but you can do it the other way too if you want to. So let's see, if you go down, what would be the rise if you go down? That'd be down 3. What's the run? 15. So you're going to the right 15. Okay, so if you did it this way, you would just say -3, 15. The slope would be -3 over 15. So therefore, the answer is what? -1/5. Okay? And if you did it the other way, all you're going to get is up 3 left 15, but you'll get the same answer, won't you? I mean, that's what I want you to know is regardless of how you count that out, you're going to get the same answer. Okay, everybody with me there? What I mean by rise and run. Okay. All right, let's take a look at this one then. Okay. All right, you got a line that's horizontal. So what would the rise be from point to point? 0. That'd be 0. The run, like if you're going from this point to that point, would be 1. So you'd have 0 over 1, so you'd have 0 slope like that. That's that stupid face that I had. The mouth was going horizontal, so it's 0. Okay, but that's y. Okay. Okay, the next one. Let's see on this one. Let's take like this point and let's pick a point there. Okay, what would the rise be on this? That'd be up 3. What would the run be? 0, because you're not moving left or right. So if you crunched it out, you'd have 3 over 0. What does that tell you? It's undefined. Okay, you can't divide by 0, so you get that. Okay, so that's the reason why that's an undefined slope. Okay, all right, let's look at the formula. Next thing I want to do is teach you how the formula goes, and just make sure you know how to either count these out or do a graph. Now I'm going to have you do a graph on this, and then I'm going to just show you why the formula works the way it does. So let's plot the first point, which is -3, -3, and let's label that so we can get kind of a good picture here. The next one is going over 4 on the x-axis, and then going down 5 like that, so you have the point 4, -5, which would mean that your slope of your line is going like that. Okay. Now, is that a negative slope or a positive slope? Negative. It's negative, because it's going downhill from left to right. So what you do is, I want you to write down the formula, because we're going to do the formula this time. So the formula for a slope is m equals y2 minus y1 over x2 minus x1. M is just the letter we use to represent slope of a line in mathematics. So what you're doing is this. And what I want you to understand is this is the rise. And what the rise is it's the difference between the y values. You're just simply looking how far apart are -5 and -3. Those are 2 apart, aren't they? The run, this part when you do x2 minus x1 is the run. All you're doing is you're just figuring out how far apart those two x values are. So that's what that's doing. Rise is the y values distance. Run is the x values distance. Now you can do this kind of like this. Usually the first point, you can call that x1, y1. That just means the x and y value of the first point. And this one would be x2, y2. You don't even have to do that, but just to kind of show you how everything in the formula, that's what the meaning of that is. So I'm just going to say on this that x1 is -3, x2 is 4, y1 is -3, and then y2 is -5. Now the way I would do this is like this. I would just go subtract the y's, and you can pick the order. It doesn't matter which way you decide to subtract it. So I'm going to have you go -5, subtract -3, and then when I do the run, I'm doing the x values, but I have to do it in the same order when I do subtraction. So be sure you don't mix that up. If you decide on the direction you're going to subtract, be sure you do both of them the same and be consistent, because if you don't, you'll kind of mess it up. So that would be -5 plus 3 over 4 plus 3. That looks like that would be -2 over 7 is the slope of that line. Now what you want to do is you want to make a real simple connection. If you were going from that point to that point, does that slope make sense? Down to right 7. Okay, that's what you should get. Okay, you don't have to graph to do that. If you're given 2 points, you can simply use that slope formula to figure that out. Okay. Okay, so I want you guys to just crunch this out, this next one. You don't need to draw a graph. You can, if you want to draw a graph and plot the points, you can, but I just want you to crunch out the formula, and you don't have to fill in what x1, x2, y1, and y2 is. I don't care about that. I just want you to make sure that you're confident how to use that formula, okay? And we kind of do a pretty wide overview in this section about everything you need to know about linear functions. So we got anything? What do you got? Undefined. You should have got 0 in the denominator, right? So all you got to show on your paper is you're just doing 6 minus -8. Now, if you did it backwards, it's okay. If you do -8 minus 6, that's fine. Then if I do the run, I'm doing -5 minus -5 like that. So that's 6 plus 8. Whoops, I'm getting ahead of myself. 6 plus 8 over -5 plus 5. So that's 14 over 0. So that's an undefined slope. Okay. Now, what if you plotted those points? What would the line look like if you connected those 2 dots? Yeah, it would go like that, and that's what you'd expect from an undefined slope. Okay. Everybody solid? Okay. Okay. All right. Now, the next thing we're going to begin to look at is we're going to get to a little bit of graphing and work on that just for a few minutes. So what we're going to do with this to kind of prepare us for other things, let's go ahead and let's plot this point, -2, -8. So you just want to go left 2, down 8, and then put your dot there. I'm going to label that P like that. And then if you have a slope of 3/5, remember the slope is the rise over the run. So what are you going to do to get the next point then if the slope's 3/5? You go up 3 for the rise, and then what? Right 5 for the run. Okay, they're both positive, so that just means you're going to go up 3, and then you're going to go right 5 like that. And you start from the point you already plotted. Don't start from the origin. Just go 1, 2, 3 up, 1, 2, 3, 4, 5 there. Then you got your next point, and that's what your line is going to look like. So when you're graphing linear functions, if you know one point in the slope, that's all it takes to graph a linear function. Okay, you don't have to make tables of values and that kind of thing like that. Okay, go ahead and do number 8. We'll see if you catch one little thing on that one. But just plot the point, use that slope to get the next point and draw your line. Okay, just take a minute to do that. Now, since you have a negative slope, are you going up or are you going down? You're going down, okay? The reason I want you to do this, sometimes students get confused about where the negative is. I put the negative in front of the fraction bar. Just do it this way. You can just go -3 over 2. And then what you would do for the rise, since the rise is negative, what would you do? You would go down 3, and then the run's positive, so you go to the right 2 like that. So what you should do on that is just go from this point down 1, 2, 3, then to the right 2 like that. Okay? Now if you have a negative slope, the negative needs to either be in the numerator or the denominator, but not both. Okay? Does that make sense? Okay? Because a lot of times on a fraction, we just put the negative right in front of the fraction bar. You okay? Did you have something? Or okay? Just making sure. Okay? All right. Now, the next thing on this one, let's do, go ahead and do 9 and 10 and 11. I'll just give you a couple minutes because I want you to do these pretty quickly. I'm giving you a point, giving you a slope. See if you got it down. Some of them you don't even have to count on. If you got it down the way I want you to have it down, you can do it very quickly. Okay? I do need you guys to, I forgot to bring my attendance sheet, so if you'll just print your name, if you don't mind printing, so I can read when I put in the attendance. Okay, let me make sure you caught something on this number 9. Now you put your point on the y-intercept. If you have a slope of 2, how do you count that out? You got to go 2 over 1, okay? All right, so what you'd have to do on that is you would just have to go up 2, then you go to the right 1 like that. And from that point that you already plotted, so up 2, right 1 like that. Okay, what if you wanted to get a point over here? What would you do? You do the opposite. So you can do totally the opposite and go down to left 1, and then you would get a point like that. I mean, be consistent. If you can count one way, you can count the other way, okay? Right? So the next one, let's say we have the point 9, 2. I have to add a little knot there. How does the line go if the slope's 0? It goes that way. You don't even have to count it out. It's just, I got a line that goes like that, okay? All right? Then the next one, you have the point 5, negative 2. If the slope's undefined, how does that line go? It goes straight up and down, okay? So you want to be just kind of solid on how those different types of lines orient themselves. That's all that's possible is slope up, slope down, horizontal or vertical. That's it, okay? All right, any questions about the idea of slope? Because now we're going to kind of get into the idea of equations where you do a little bit more work on it. So a couple of basic things that you want to be familiar with is when you have an equation of a linear function, this is what's generally called the general form. This is the slope-intercept form. That's the one usually students remember most often. This one, that's supposed to say point slope, not slope. Okay, so that's the point slope formula, which you use every now and then when you're working for that. And then I want to talk about what a vertical line is and what a horizontal line is. So if you have the equation x equals a, that's a vertical line. So let me give you an example and write this down. If you had x equals 2, for instance, you only have one variable in there. And one of the things I like the students to kind of get straight in their mind, if your equation only has one variable, what that generally is going to mean is it only touches that axis. So if you only touch the x-axis at 2, then how would the line have to go? If it doesn't cross y, what would it have to do? It'd have to go straight up and down, right? So I kind of look at this as if you have x equals a number other than 0, then you're guaranteed you just come in contact with x, so it's going to be vertical straight up and down like that. That's a very easy graph to do, but students are really bad about getting these things mixed up. So the idea is if you had x equals 10, what are you going to do? You're going to go to 10 and straight through it. You touch the x-axis only, okay? There's no y-intercept on that. Horizontal lines work the opposite way. So if you had y equals 5, for instance, and try to use this way to kind of help you sort this out in your mind. So what you would do is y is 5 right there. But since there's not an x in the equation, it only touches y. So does it make sense it would have to go like that? Okay. So if there's one variable, it's going to touch that axis. The only exception to that would be if you had x equals 0, then that would be the y-axis. Or if you had y equals 0, that would just be the x-axis. Okay. But in general, one variable means you touch that axis only. Is everybody with me there? Okay. All right. If you have two variables, it's going to touch both. Okay. Now I'm going to show you how this graph goes on both of these and just kind of show you a real quick way to get these two graphs done. So when you're learning this stuff, you want to know if there's only one variable, it's either vertical or horizontal, but if there's two, it's going to slant. Okay. And you can actually do this in your head. If you want to find a x-intercept on this equation, what you do is you just replace the y with 0. So you would write 2x plus 4 times 0 is equal to 8. That would cross out, leaving you 2x equals 8. And then if you solve that equation, you can do that in your head or divide by 2. What you get is you get x equals 4. So that means that the line is coming in contact with x like that. Okay, that's how we learned how to find an x-intercept. The way you find a y-intercept is you replace x with 0. So if you go to find the y-intercept on this, you replace x with 0, leave y alone, and then you solve that equation. So that's going to give you 4y equals 8. Divide by 4, you can do that in your head, you'll get y equals 2. So what I'm trying to get you solid on is there's two variables. See, it touches both axes. And that's what forces that to slant like that. Now I want to show you how you can do this in your head. Okay, just these two equations right here, this is what you call the general form. You have ax plus by equals c. Here's how you can do this in your head. When you find an x-intercept, just block y off. What's the answer to that equation in your head? 4. X equals 4. Put a dot there. If you want to find the y-intercept, block that off. What's the answer to that equation? Y equals 2. Put a dot and connect, and you got it. Okay? Anytime you're in standard form, where you have ax plus by equals c, you can a lot of times do that in your head. Now let's try to do this one in our head. So if you want to do the x-intercept, you let y be 0, so block that off. What's the answer to that equation right there? Negative 6. So what you would do is you would simply, where's my pen? There it is. 1, 2, 3, 4, 5, 6. You would put a dot there. Now do the y-intercept. So let x be 0, block that off. What's the answer to that equation? Y equals negative 2. So you can do that in your head. And if you have y equals negative 2, your line would look like that. So it would be slanting. So again, you got two variables. You're guaranteed to come in contact with x and y. That's the idea. So I want to kind of give you a system to kind of sort this out. Two variables touches both axes. X, if it's x equals a number, what does it touch? Just x. If it's y equals a number, what does it touch? Y-axis. Do you guys understand what I'm talking about there? Because you want to get a way to sort all this out in your mind so that you can quickly know what that graph looks like, okay? Okay. Now what we're going to do next is we're going to get into finding equations of lines. That's kind of the big deal. So on this one, let's just kind of sketch a graph of this. And what we're going to do is we're going to find the slope-intercept form of the equation of the line that has these properties. So let's go ahead and plot our point. So we have a point on this. We have negative 3, 2 like that. Okay. Now we have a horizontal line. So go ahead and just draw a horizontal line like that. Okay. What axis does it come in contact with? Y. So therefore, what's the answer to the equation? Y equals 2. Good. Okay. So that would be y equals 2. And the other thing that you want to understand about this is if it's a horizontal line, isn't y always 2? Okay. That's what this graph of. Y is always 2. That's what that equation says. It says y is 2 and nothing else. Okay. It's a constant. Okay. So that's how you do the problem. You don't have to do any computation. It's just knowledge of how that graph goes. Okay, now this one's a little bit more involved. You got to do a little bit of work on this one, but I'd like you to graph just in class to kind of give you a little bit better understanding of how this works. So let's go ahead and let's plot our points. So this first one, you're going to go over 3, up 8, and we'll put a dot there. Then the second point, we're going to go left 1. Then we're going to go up 7 like that. And then you want to go ahead and connect the line like that. Okay, now that problem right there is going to have two variables, x and y. It has a y-intercept. You can tell it has a y-intercept, right? It touches y. Eventually, it's going to touch x, right? So your answer is going to have both an x and a y in it. So I'm going to show you one way to do this. There's more than one way to do it. I'm going to go ahead and show you both ways, and I don't care which way you do it. I just want you to know how to do it correctly, okay? So let's start this by writing down what we call the slope-intercept form. And then just maybe draw a line, and then to the right of that, I want you to write what we call the point slope formula, so I can go ahead and show you how to do this problem both ways, and then you can decide which way you like best, okay? Okay, step 1 is, what does M represent? Slope. The slope. So you must find the slope, okay? I don't care how you find the slope. You can count it, or you can use the slope formula. So on this one, let's go ahead, let's just use that slope formula. And when you're doing the slope formula, you don't have to write it down. I just am doing that mostly to have you refer to that. But what you do to find the rise is you subtract the y values, okay? So I'm just going to do 7 subtract 8. When I do the run, I subtract the x values in exactly the same order, so I get -1 minus 3. Okay, so that's going to leave me with m equals -1 over -4. The two negatives divide to make a positive, so you would have m equals 1/4. Now, if you look at the line we drew, does that make sense to you? That you would be going up 1, right 4? Okay, now you can do that by counting too if you want to, but you want to not rely totally on counting, because what if you have fractions and stuff in there? You got to know how to compute it, okay? So now the next thing we need to do is we've got that figured out. That's a fourth. We need to find b. We need to find the y-intercept. The y-intercept looks to me like it's 7 point something. Okay, we want to find exactly what it is. So this is the way I want you to do this. Write down, just over at the side, write down y equals mx plus b. Now what we're going to do is, we know the slope now, so that's 1/4. You plug it in. You also know 2 points, so you pick a point and you plug a point in. And it doesn't matter which one you pick, because it will give you the same answer. So in this point, 3, 8, it goes like this. Okay, 8 is a y value, so that goes there. 3 is an x value, so that goes there. So you're going to have an equation that just has b in it, so you can find what b is. Okay, does that make sense what I'm doing? Now again, it's your call on which point you plug in, because it'll work either way. So now if I do this, I'll have 8 is equal to 1/4 times 3, because x is 3, plus b. You got to be solid on fraction arithmetic if you want to do it this way. That'll give me what b is. So that's going to give 8 equals 3/4 plus b, because you multiply fractions straight across. And then you're just going to subtract 3/4 from both sides, or like I've been showing you, just move the 3/4 to the other side. So you'd have 8 over 1 minus 3/4 is equal to b. Now what do? You got to get a common denominator there, right? Okay, so what's your common denominator? 4. So you multiply that by 4 over 4, and that's going to give you 32 over 4 minus 3 over 4. So that's going to give you what b is then. B is going to end up being, what was that, 29 over 4. Okay, so there's two things that we have. We have this and we have that. That allows us to get the answer to the problem. Okay, so if I want the answer in slope-intercept form, I'm wanting you to have y equals mx plus b. So now you just put everything in. So you'd have y equals the slope 1/4 times x, that's your variable, plus the y-intercept, 29 over 4, like that. That's your answer to your problem, okay? So tell me if you followed what I did okay on that, okay? So basically, you want to find the slope, and then you plug a point in to find b. That's one method. Students most often do it that way. I'm going to show you one other way, and I don't care which way you do it. And then I also want to show you how you can tell you're right. Now, take your calculator or something and do 29 divided by 4 real quick. That's 7.25?
Yeah.
Yeah, 7.25. Does that look right as a y-intercept?
Yeah.
Yeah, okay. So, I mean, visually, you can kind of tell you're on the right track, okay? Okay, let me show you the second way. Okay, if you prefer to do it this way, you can. Sometimes students like doing it this way better. Okay, well, the thing is, we have the slope as 1/4. We already did that. Now you pick a point. Now, just for something different, I'm going to plug in this point. If you plug 3/8 in, it'll work the same way. So what you would do is that goes in there, and then the 7 goes in there. Then you'll have an equation that's easy to solve. So you would end up having y minus 7 equals 1/4 times x, subtract -1 like that. And you got, remember the formula says x minus x1. I see students slip up on that a lot. It's subtracting a negative, okay? So now what that's going to give is y minus 7 equals 1/4 times x plus 1. Okay, everybody with me there? Okay? Now, if you want to, you can do the distributive property. That's if you want to. I wouldn't even bother that. You can make that 4 go away by doing what? Multiplying by 4 so it goes away, right? If you have an equation that has a fraction in it, you can make that go away. So what I'm going to have you do is let's just multiply that by 4. But if you do that, you have to multiply everything on the left side by 4 also. So if you do it this way, you would have 4y minus 28. That would cross that out. That's left. That will be equal to x plus 1 like that. Let's see if we don't get the right answer. Okay, so what I'm going to do now is solve for y. So I'm going to add 28 to both sides. That's going to give 4y equals x plus 29. Then what? Divide by 4. You've got the same answer. That's y equals, that's really 1/4 x plus 29 over 4. Okay? I don't know. Do you think one way's easier than the other? Are they the same or what? No opinion? No interest? I don't care which way you do it, just get it right. Okay, so to me, both ways are about the same amount of work. So either way is okay if you do that. Would you like to know how you can tell you're right? Okay, good. Somebody shook their head. That's good, okay? Because like if you're in a situation in math and you want to know you're right, you might as well take advantage of that. So actually what you do is this. So you can pay attention to this, write this down if you want to. The way you check this is you just pick a point. So I'm going to take 3/8, and let's write down our answer. Let me show you why it's right. Okay, basically what happens is if you plug that point into your answer, it should check. So the idea would be 8 is y, so that goes in there. 3 is x, that goes in there. Let's see if that doesn't check. That would give 8 is y. We'd have 1/4 times x, which is 3, plus 29 over 4. Okay, let's see if it works. Okay, that would be 8 equals 3/4 plus 29 over 4. What's the right side right there? 32 over 4, is that 8? Yep, so it's right. Okay, that's how you can tell you're right on these problems. And if you plug the -1/7 in, the same thing happens. That's it. Okay, you're doing a test, why wouldn't you do that? I say that every time I teach this, and students say, yeah, I'm going to check, and they never do. Part of that thing is students sometimes forget. Sometimes students just don't want to check, okay? But you can do that real quickly on these problems. You tell you're right. I'd just say go for it, right? Okay, well, this one's slightly different in that it's wanting a general form. So let me go through that. Is there any question on the problem I just did? Does everybody feel okay with that? Okay, just take your pick as to which way you want to do that. Okay, this one, let's do a graph to kind of help us understand visually what's going on. So we got -3, -5. Got a dot there. Then you have 0, -7 like that. Now this problem can be done exactly like the last one. The reason I'm picking this problem out to do is to see how observant you are. Okay? So let's write down the formula y equals mx plus b. Okay, let's look at it that way. I want you to look at the graph we just drew. Do you know what b is in this problem automatically? Yeah, what is it? -7. That'll make the problem a heck of a lot easier, so you want to take advantage of it. You want to be observant and find easy, fast things to do. So yeah, that's -7. I did give you a y-intercept. So you don't need to go through that mess I did on the last problem. Well, we need to find the slope. Take your pick on how you want to do the slope. You can just count this out. Count that slope out in your head and tell me what it is. Looks like that is down 2. Does that look right? And then is that right 3? Does that look right? Okay. So you would have y equals -2/3 x minus 7. Just by observing, you can get that answer very quick on that problem. Now that's not the answer I'm looking for because I'm looking for general form. When you do your homework on my math lab, pay attention to the directions. What is general form asking for?
AX plus BY.
Thank you. AX plus BY equals C. All that means is all your x's on the left side, number on the right, and no fractions. You want to get rid of your fractions. So what you would do is just move that there. So you would have 2/3 x plus y is equal to -7. Okay, now that's not done because general form, we just don't want any fractions. Okay, if we can handle that, and we can in this case. How do you get rid of the fractions? Multiply both sides by 3. Good. Okay, so if you do that, when you do this part, the 3's are going to cancel. That's going to leave you 2x. And then you got to multiply the 3. You're doing a distributive property. 3y equals negative 21. That's the answer that I would want in general form. Okay? So if you see something like that, a problem like that, you can speed up the process of getting the answer on, and you want to do that. Okay, yes?
How did you know that the y was negative 7?
But there's two reasons, because when you have a y-intercept, you'll always have 0 comma something. Okay? When we graphed that, see, that was right on the y-axis. So that right there, that b is what that y value is. It's negative 7. What I spotted is when I see a point that's 0 comma something, that number right there is the y-intercept. Yeah. That's how I know. If you didn't see that, if you did the problem like the one I did above, you would figure it out anyway. But you want to look for kind of quick ways if you spot something to save a little bit of time. Okay? Quick question. How do you know you're right? Plug a point in. Okay? Let's plug one in. Okay, let's see. We have a point negative 3, negative 5. So if you just put negative 3 there and negative 5 there, let's see if it doesn't work. That would be 2 times negative 3 plus 3 times negative 5 equals negative 21. That appears to be negative 6 plus negative 15. Look at that, it's right. That took like 10 seconds. I know I'm right. It also helps you understand it, because a lot of times students understand the process of graphing, but they couldn't explain to me what it is. What a graph is it's a picture of all of the solutions of an equation. That's what graphs always are. So that point negative 3, negative 5 is a solution of the equation, so therefore it's on the graph. Does that make sense? That's what graphs are. They are pictures of solutions. Okay? Okay, well, let's do just kind of a few little applications. This is just kind of if you're learning linear at the beginning, this is kind of a simple example to go through and look at. A lot of times in finance and stuff, things might follow what we call a linear model. And you'll see this is something like that might follow a linear model like on a cell phone billing or something. So what this problem says is if your call lasts 5 minutes, costs $2.50. Now, when cell phones first came out, they used to be billed that way a lot. Like they would track how often you talk. Now most people have unlimited talk and text and stuff like that. Then they say if you called for 15 minutes, that would cost $6.50. And then it says you're going to let Y be the cost of making a call that lasts X minutes. So you're going to write a linear equation for that represents that. So what you really have is you have 2 points. Your first point is 5, 250. So you want to write that down. Your next one is 15, 650. So you also want to write that down. Now what we're going to do is we're going to do exactly the same process that we did on a previous problem. Let's go ahead and let's go this way. I think usually students kind of like to do that formula more than the slope intercept or the point slope. So let's do it that way. So what are the 2 things that you have to know to get the answer to this problem in that equation? Slope, y-intercept, right? So we need to find the slope. We can find the slope by doing the slope formula. Okay? Remember, all you're doing on the slope is you're subtracting the y values. Here's my y values. Subtract them. You find the distance between them. Pick the order you want to do that in. And that's going to give the rise. Okay? Subtract the x's in the same order. So which are you going to do? 5 minus 15 or 15 minus 5? Yeah, be consistent. Don't screw that up. So that's going to be $4 there. Then that's going to be 10 there. So that's actually 0.4. Now I'm just going to write that as 0.40 because we're talking money. So that's 40 cents. Okay? And we'll talk in a little bit about what that 40 cents means in the context of that slope. So that's step number 1 is we know that m is 0.40. Okay, so we have that. Okay? Now what we want to do is to find b. We start over again with this equation. We now know that m is 0.40. What else do you do to find B? Plug a point in. Does it matter which one? No way, just pick one. Okay, let's go this one. X is 5, so put the 5 there. Y is 250, put the 250 there. It's linear, so it doesn't matter which one you plug in. Okay, so that would give me the equation 250 equals 0.40x. No. What's x? 5. Okay, so we're going to have 0.40 times 5, and then plus b like that. Okay, so we just solved that equation for b. Okay, pick a point, and it'll work the same way. That looks like that's 250 is equal to $2 plus b. You can do that in your head. B is 50 cents, right? Okay, so you would get b is equal to 50 cents. So the two things that you have is you have that and you have that. So what's the answer? Y equals 0.40x plus 0.50. Right, it's y equals mx plus b. So the answer to your problem would be y equals the slope times x plus the y-intercept like that. Okay? Now let me talk a little bit about what this means. Okay? What if you didn't call at all? Okay, what if you just picked up your phone and didn't call at all? How much would it cost? 50 cents. That's what's called a fixed cost. You know what the 40 does? It basically does this. Since the slope is 40 cents, remember, a slope's a rise over a run. What it means is every time you talk a minute, how much do you get billed? 40 cents, okay? That's what it is. So that's what the slope is doing, is it's giving you the rate at which you're being charged. Like that. Sensible? Logical? What's that? It would be awesome if it worked that way, wouldn't it? Yeah. Yeah, that's why it worked. Okay, so let's see. Let's go to this next one, and I'm going to have you guys try to do this problem. So I've kind of done enough on there. I want to give you one problem to do. Go ahead and plot your point, draw your graph, and then I would start with y equals mx plus b, and then try to get your answer. Get your final answer. And your final answer needs to be in the slope-intercept form. So take a couple minutes, see if you can get that done, okay? And don't wait for me, please. Do it. I'm watching. Carefully. Go for it. If you can do this, then you kind of got beginning to get this put together. So I know the answer just by graphing. Has anybody got an answer yet? What do you got?
Y equals 6x plus 6.
6x plus 6, good. Yeah, that's what you should get, okay? Now, so really you've already got the slope, so that goes in there. You got a point, so the negative 6 goes in there. The x goes in there. So what you would have is, it looks like negative 6 equals 6 times negative 2 plus b. That would be negative 6 equals negative 12 plus b. You can add 12 to both sides, so it looks like you're going to get 6 equals b. Okay? So now you're ready to get the answer. So the answer would be y equals the slope I gave you plus the y-intercept. Now what I did on this problem is I just went and graphed it. So there's my point, negative 2, negative 6. The slope is up 6 over 1. If I do that twice, I'm at my y-intercept. So, okay, so you can do it that way. Okay? All right, everybody with me? Okay, how would you check your answer? Plug the point in, see if it works. Okay, that's the idea. Okay, okay, we got two other major areas to go through because this is a big overview of linear functions. So let me see if you know this kind of thing. If I give you an equation this is in general form. If I want you to find the slope, what you're going to do is you're going to solve for y. So anytime you have an equation that's in general form, put it in the form y equals mx plus b, then you'll easily find the slope, okay? So this is easy to do. You just move the x to the other side. So that would give 5y is equal to negative 17x plus 2. And then you divide both sides by 5. And when you're doing that, be sure everything gets divided by 5. So you'd have y equals negative 17 fifths over x plus 2 fifths. What's the slope? This thing right there. There it is. Because remember, you're putting that in y equals mx plus b. So therefore, the slope would be negative 17 over 5. Okay? So if you've got your equation in general form and need to find the slope, which you'll have to do quite a bit from time to time, then you just need to do that. Okay? That's what the slope-intercept form does for you. Okay, if you look at number 18, can you tell me automatically what the slope is? Yes. Yeah, okay, it's already solved for y. It's already in the form y equals mx plus b, so that's negative 3/2. Can you tell me what the y-intercept is? 2. But what I want you to write is I always want you to write a y-intercept, not just as the number, I want you to write as a point, okay? Because a y-intercept's a point, it's not just a number, okay? It's a point on the graph, so that's 0, 2, okay? All right. Okay, next one. How are you going to find the slope on this? You're going to solve for y. Okay, so again, just the same thing here. That's 7y, that's equal to negative 3x plus 5. Go ahead and divide everything by 7. Okay, so what's the slope? Okay, what's the y-intercept?
0.
Okay, I want you to write that as a point, as what we call an ordered pair like that. Okay, all right. Students do that fine. I'll tell you the ones that students mess up on the most are number 20 and 21. I see it all the time. Okay, and one way that'll help you with this is let's see if we even remember how to do the graph. I mean, I taught you earlier. If the only letter is y in the equation, how does the graph go? It goes that way. It only touches y. Okay, so you can reason this problem out this way. There's my graph. Well, what's the slope if the line's horizontal? 0. What's the y-intercept? Where does it cross the y-axis? At negative 2. So that would be 0, negative 2. Okay? Now, the other way you could look at this is this equation could be written as y equals 0x minus 2. Okay? If the slope is not in the equation, it's got to be 0. So you got those two choices on how to do that. Okay? Okay, next one. It only has an x, therefore how does the graph go? Straight up and down through negative 3. Okay? What's the slope of that line? Undefined. That's the one we said was undefined. Okay? What's the y-intercept?
Non-existent.
Yeah, there isn't one. It doesn't touch, okay? So that would be there isn't one. Okay, you don't have to have a y-intercept. It's a vertical line, you're probably not going to have one. So that's it. So those are kind of the 4 things that you have to do if you're finding a slope with an equation. That's all you're going to encounter is those kind of situations like that. Okay, okay, let's do sketching, and then we're going to do parallel perpendicular and see if you remember anything about that from your past. Okay, so if I want you to draw a graph, there's 2 ways to do this. I'm just going to choose to do it this way. So like on your My Math app homework, you're going to do some graphing. And the way they do that is they have you just put your first dot on there and click your mouse, then move up and click your second dot, and it'll automatically draw the line. It's pretty easy to learn how to do that. So what we're going to go ahead and do is we're going to solve this for y so we can find the slope. So go ahead and move your 2x to the other side. So that's negative 3y equals negative 2x minus 3. Then divide everything by negative 3. Like that. So you're going to end up getting y equals, you have a positive 2/3 because the 2 negatives divide out to make a positive. That's 2/3 x. What happens to the 3? It becomes plus 1. Okay? So what that means is your slope is 2/3. Your y-intercept is going to be 1. Now what we're going to do is we're going to draw a graph. We've been doing this backwards. Now we're going to do it forwards. Okay? So when you graph this, all you got to do is put a dot on the y-intercept like that. And if your slope's 2/3, how do you go? Up to right 3. Okay, it's rise over run. So that just means you're going to go up to right 3, but be sure that you do the counting from the dot you already drew, not from the origin. I see students do that all the time. So it's up to right 3. There's your line like that. Okay, now I'm going to do something real quick to finish this up. That's how you do that. But this point right here has an x value of 3, and it has a y value of 3 also. Let's plug it in and see what happens. Okay, so if I plug that in, x is 3, y is 3, look what happens. That's going to be 2 times 3 minus 3 times 3. Notice that that's 6 minus 9. That's -3. That's what it's supposed to be. So in other words, it checked. So what I said is a graph is a picture of solutions. That 3, -3, that 3, 3 is a solution of the equation. It checked, therefore you're right. Everybody got that? So when you graph anything, you can tell you're right, okay? You can just check your points. On a line, it's easy. Just pick one. If it works, it should be good. Okay, let's look at this next thing to kind of wrap this up. Okay, so here's what I want you to write down here. I want you to write down 2 equations. I want you to first write down y equals, let's say 2/3 x minus 2. And let's write down y equals 2/3 x plus 1. And let's go ahead and just kind of just sketch a graph on this like we just did, okay? Many of you are going to remember this, some of you aren't, okay? So let's go ahead and let's graph the first thing, okay? If you graph this, the y-intercept's -2, so what do? You put a dot there, right? What do you do with 2/3? Up to right 3. So what you would do is you would go up to right 3, put a dot. That would be the graph of the first equation like that, like I just taught you, okay? Now, if you did the second equation, what's the y-intercept? It's 1. The slope is 2/3, so what are you going to do? You're going to go up to right 3. So you're going to have a line that looks like that. Now, those lines are parallel, right? They don't ever intersect. Look at the 2 equations I gave you. How could you tell just by looking that they're going to be parallel? They have the same slope. Now, the intercepts have to be different, so you have to have that same slope. If you have the same intercept, and it's the same line. So that's what parallel lines look like, is like that, okay? Now, I would like you to write this down. This is an easy way to figure this out. Let's write down y equals 1/2 x, and let's write y equals -2x plus 2. Okay, and I'll kind of show you where I'm going with this thing now. So we're going to go ahead and we're going to graph these 2 things and kind of see basically what happens on this. Just get kind of a good enough sketch so that you can see what happens. Okay, so if you look at this line, the slope's 1/2, right? What's the y-intercept if it's not there? 0. Okay, 0 y-intercept, slope of 1/2. So let's graph this first one. I'm going to graph the first one in red. So you would start with a y-intercept of 0. If it slopes 1/2, you would go up 1, right 2 like that. Okay, that's what your first line would look like, is like that. Okay, now let's graph the second one. The second one has a y-intercept of 2. So it's going to go like that. The slope is -2/1, so what are you going to do? Down and over, down 2, right 1. So from that point, go down 2, right 1, connect the dots. What do you notice, if anything?
They intersect.
They intersect, but how do they intersect? Yeah, they're perpendicular at a right angle, okay? So that's at a right angle. So what you learn to look for is, look at these slopes. What do you notice about those slopes? They're reciprocals. One of them's positive, one of them's negative. So we call those negative reciprocals. So in other words, if you had a slope of 2/3, you turn it upside down and make it opposite. If you had a line with that slope and one with that slope, they're going to be perpendicular. Does that make sense? Okay, so parallel have to have same slope, perpendicular have to have that relation like that, okay? Okay, so what we're mainly going to do with this idea, and I'm going to go ahead and run down to number 24. I'm not going to do much with 23 here. So I want to do this one to start with. And so what I want you to do first on this one is let's write down the equation. Let's go ahead and graph this equation. Okay, let's do that before we're going to find an equation that's parallel to that line that goes through that x-intercept. Okay, so if you want to graph this, that's what we've been working on. You want to move the x the other side. So you'd have 2y equals negative 3x minus 2. Then you would divide by 2. So you're going to have y equals negative 3 halves x minus 1 like that. Okay, what's the y-intercept? Negative 1. Slope, how do you do the slope? Down 3, right 2. Rise over run. So you're just going to go down 1, 2, 3 over 2. And then just kind of carefully sketch in a line like that. So that's your equation. Now let me explain what we're doing on this problem. Okay, they're giving us an x-intercept. So let's put an x-intercept of negative 3. That just means put a dot right there and label that point 3, 0 like that. So what we're going to do is you can visualize in your mind that that line, if it's parallel, is going to go right like that, right? Our job is to find the equation of that line, not just graph it. We'll graph it before we find that equation, but let's do that. What's that? Oh, thank you. My y-intercept should be where? Over there. Okay, sorry about that. Okay, so let's put that at negative 3, 0 like that. Okay, if we wanted to graph something parallel, how would the slope go? It'd be the same. So you would still go down 3, right 2. So from that point, go down 3, right 2, and then just kind of sketch it like that. Just kind of make it as close as you can like that. So that's what it's going to look like. So if we're going to find the equation, the second major thing we do is we go ahead and find the equation. We're going to go like this. Okay, I'm just going to do y equals mx plus b and keep doing it that way. So if we're doing a parallel line, here's the deal. And it's actually real similar to what we just got through doing. The slope we already know is negative 3 halves, right? We know a point that's on the line. So what are we going to do with that negative 3, 0? We're going to plug it in like we've been doing. So if you take this point negative 3, 0, you want to plug the negative 3 in there. You want to plug the 0 in there, and then you'll get your y-intercept, and then you can put it together to get the answer. So the key thing is the slope of the perpendicular line is also negative 3 halves. Now, if you solve this, you would have 0 equals negative 3 halves times negative 3 over 1 plus b. Okay, solve that equation for b. So you're going to have 0 equals 9 over 2. So what's b? Negative 9 halves, right? You can move the 9 halves to the other side. So you'd have negative 9 halves is equal to b like that. So what you have is this and this go together to make the answer. So the answer would be y equals the slope times x minus the y-intercept like that. Okay? Now, 9 over 2 is 4.5, right? That's 4.5. Okay, I didn't do a very good job of drawing my line. That thing would actually cross right at 4.5. Okay, so visually, you can tell you're on the right track. Okay? All right, does that look okay? Okay, there's a lot of repetition in this equation of line. We just kind of look at different situations. Okay, I want to go 26, and that'll finish this up tonight. I'm going to skip 25. And this one's perpendicular. It's very similar. So let's go ahead and let's solve this equation for y, and let's get our graph. So let's go ahead and just move the 5x over here. So you have negative 4y equals negative 5x plus 6. Divide by negative 4. So I have y equals 5/4 x. And then that will reduce to negative 3 halves. That's a minus. So you'd have that. Okay? Now, what we're going to do on this one is let's just kind of jump right into finding the answer. Okay? So what we have on this, what is the slope of this line I gave you? Okay, so m is 5/4. Now, what would be the slope of the line perpendicular to that? What would it have to be? Flip it. Good. Okay, so it'd be negative 4/5. Got to change the sign also. So that would be negative 4/5 like that. Okay, that's because it's a perpendicular line. So what we want to do then is you want to just have y equals mx plus b. See, we know that's going to be the slope of the perpendicular. We know that. That's part of what we're looking for. And then what do you do at this point 6, negative 6? Well, you just plug it in. So negative 6 goes there. The slope of negative 4/5 goes there. And then x equals 6 goes there. So when you put that together, you're going to have the equation negative 6 equals negative 4/5 times 6 plus b like that. Solve that equation for b, then you can put it together and get your answer. So that looks like that's going to be negative 6 equals negative 24/5 plus b when you multiply the fractions. If you move this to the other side, you'll have negative 6 plus 24/5 is equal to b. And get a common denominator. That common denominator is 5. Okay, so it looks like what you're going to have is negative 30 over 5 plus 24 over 5 equals b. So what is that? That is negative 6 over 5 equals b. Okay, what's the final answer to this problem? Y equals negative 4/5 x minus 6/5. There you go. So the only difference is perpendicular. The slopes have to change to a negative reciprocal. So your final answer would be negative 4/5 x minus 6/5. That's it. Okay. So I've shown you everything you need to know about linear functions tonight. Okay. All right. There's a lot of repetition on that, but the hardest part of that section for most students is doing the equation stuff that we just did. So finding the equation. Okay. All right. You guys doing okay?